Assalamu alaikum. I'm very sorry for the delay. So I have a very sick relative who is actually admitted in CMH, which is why I did not get much time to prepare, and which is why I was very late. Still, I will try to teach you as much as I can, starting with this video, which is actually sort of like an introduction. Okay, so as I have many relatives at home, it was difficult for me to procure a room to myself. So I was thinking about what I could do. So instead of actually doing a streaming, I've thought about creating a video lecture, which might be very bad. So please try to, try to keep your attention towards it. And if you have any questions, you can ask me. And of course, sorry for the background noise. I couldn't find any good place to actually record. So now I'll be explaining how I'll be taking classes. So all of my classes will actually be just recordings of my screen. I will not be taking classes on an actual board and streaming that. Okay, so all the classes will just be recordings of maybe on the paint screen and then maybe PowerPoint slides. So if you have any questions, please feel free to ask them after watching the videos and comment them in the Google Classroom, because I'll be posting these videos in the Google Classroom. Okay, so let's start. If you remember, our last class was on pointers and dynamic memory allocation. So we'll still see some of that as a review and then go to move on to the new topics. So at the very beginning, we learned what is a pointer and we learned how to declare them. As you can see, the examples are here. So to write them, actually, you have to write the name of the type first, then the name of the variable. For example, here we have written, you've seen that int star a, which means that it is an integer type pointer and name of the pointer or the name of the variable is a. And there are two pointer operators which we have learned to use, the star operator or asterisk operator and the ampersand or and sign. So the star operator returns the value of the pointer and returns the address. So this is an example. We have already seen this example. So I'm going to move a bit fast here because these are things that we have already seen. These are the different types of manipulations that we can do using pointers. And this is an example of what the memories or how the memories are allocated for each of the variables. So we have already seen this. As you can see at the very end, there's a comment, or there are two comments, actually two lines of comments which represent the memories or the memory locations of the four variables that we have declared. The variables are CP and CH for character. CP is the character pointer and CH is a character variable. IP is the integer pointer and I is the integer variable. Similarly, float and double. Then we have also seen how to use arrays or pointer arrays. Use pointers to actually point to arrays. So only a single pointer is enough to actually iterate or go through a whole array. Then we have seen how to print using, or how to actually statically allocate memory. For example, in this case, we have a character pointer. We did not allocate any memory, but we initialized using a string. The string here is 1, 2, 3, and after initializing, if we print it, we can actually print it. Okay, so these are the things that we have seen. We have seen multiple indirection. Then we have seen how to take pointers as parameters. And finally, this is the slide that we haven't studied yet. We studied up to this slide, right? Which is, oh no, we haven't studied this yet. Okay, so let's start with the very first official online class, I guess. So the very first line here is actually a short definition of dynamic memory allocation. So this is a process by which memory is allocated as needed during runtime. Remember, this is during runtime, so not during compilation or after compilation, but when the program is running itself, the program doesn't know what memory or how much memory is allocated yet. So when we allocate ourselves, only then the memory is allocated. okay, or when that line is executed where the memory is allocated, only then memory is allocated. Okay, so why do we need this? To take full advantage of existing memory. How do we do that? Let's see an example. So as you can see, an example here is given for Microsoft Word processor. Okay, so what is the word processor? You can actually create and edit as many pages as required. So let's see. For example, this is a Microsoft Word document. I've already created one. As you can see, there is only one page here, right? So what does it do? What if all those pages were always open regardless of whether they are required or not? So think of it like this. So this is one page, right? So if I keep pressing enter, a new page is opened, right? And again, if I press enter like this, as many as or as much as I need, many pages will be created. So as you can see here at the very bottom left, it's written page 4 out of 4. So now 4 pages are created, even though I didn't write anything. So this is actually a dynamic memory, right? Because at the very beginning, there were only one pages like this, only one page, right? Oh, not yet. So now there are only one page, or there is only one page, and only a fixed amount of memory is allocated for it. But once I write something, then that memory is allocated. Then again, if I write something else, again more memory is allocated. Like this, if I continue, if I keep writing something in every line, and once I cross one page or finish writing in one whole page, then a new page is open. So this is actually an example of dynamic memory allocation. Now think about it like this. If there were no dynamic memory allocation, then what would happen? All the pages that I require, let's say I require 100 pages to write a document, then what will happen? 100 pages will be allocated every time I open a new Word document, right? So the RAM would become overwhelmed pretty quickly, and the solution for that problem is actually dynamic memory allocation. Okay, so now let's continue with our slide. So as we see, there is a new header file. Actually not new, we already used something here, right? Malloc, free. But there are two new functions here. Actually there are four main functions which standard library uses. Those are malloc, free, calloc, and realloc. Okay, so malloc means memory allocation, and it allocates the number of bytes that is given as input parameter and returns the pointer to that allocated memory. And function free actually frees the memory that has been allocated. And then there are two other functions, calloc and realloc. Okay, so as you can understand, realloc means it's reallocating a memory, and it requires the pointer and the number of bytes that needs to be allocated. And calloc actually sort of is like a multiplier. Okay, we'll see some examples and it will be clear. So this is actually a code which is already there in the slide on the very last page of the slide. As you can see this example, so I've already written that in this code. So as you can see, I have at first declared or actually written a preprocessor to two header files, stdio and stdlib. Okay, make the screen larger. So this is the main function, and at the very beginning I have declared a character pointer p, and then I have allocated memory of size 10. So here 10 means what? Actually this means the number of bytes. Okay, so this is a check for whether that memory was properly allocated or not. So if the memory is not properly allocated, then p will equal to null, which means no memory was allocated. So if p is equal to null, then this will return what? 1, right? Which means no memory was allocated, and it will print allocation fail and will exit the program. So this is sort of like an exception checking or error checking, okay, so that it does not crash your program. Okay, fine. So if this does not exit the program, that means we have successfully allocated a fixed amount of memory. So next we are printing or asking the user to enter a string. Then we take that string as input, and then we again print it, and then we free the memory. So let's try to run this program. See whether that's successful or not. Okay, so it ran successfully, so it's asking me for a string. So let me just give my name here, and it's printing properly. Why? Because it process return 0. So there is no problem now. Okay. So now let's change the execution a little bit. For example, let's say I have given this is my name. So how many characters are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 including spaces and 16 including null characters. So even now it's working properly, right? Okay, sorry about that. I guess I had a lot of background noise, which is why my voice was very unclear. I hope it's fixed by now. So let's check the code that we were running. So this is being executed properly, although we have already exceeded the amount of space that we have allocated, which is 10 bytes. We're still working properly. But if you overly exceed it, for example, let's say I'm writing this is my name and it is no name. So if I write this, and as you can see, it's returning an error. This is actually a segmentation error because we have already exceeded the amount of memory that we have allocated. So now let's say we are allocating 80 bytes of memory. So let's check it again. This is name and it is okay. So now it's working properly. So as you can clearly understand, this number of bytes actually matters, and if you actually exceed that amount of memory, it will give you an error. Now let's see how much memory we have allocated. So we are going to print this is the number of allocated bytes, %d for an integer, and then a new line. Okay, so we are going to print the number of bytes allocated using size of, which is actually an operator, if you can remember, a special type of operator, and then we are passing the pointer. Okay, so let's see what it prints. And now instead of actually taking input, we'll just print the size. So I'm commenting this out. Okay, build and run. So it's saying that the number of allocated bytes is 4. Can you say why? Although I've allocated 80 bytes of memory. Okay, let's see. So let's say this is my RAM, right? And I have a pointer P, which is actually pointing to some memory. And the size of the memory is actually, as we have already allocated, how much memory? 80 bytes, right? But why the size showing that it's 4 bytes? Because this P is actually a pointer, right? And there's actually another memory allocated for this P somewhere, right? To keep the address of this thing, to keep the address of this memory location. That is actually the size of the pointer itself. So this 4 bytes means that small piece of memory that has been allocated to keep the pointer's memory, not the whole memory to where the pointer is pointing to. Okay, I hope that's clear. If it's not, you can ask questions again. Okay, so this is why actually whenever we are trying to print the size of the memory allocated for P, we'll always get 4, which is the memory addressing. Okay, now if I want to actually print the memory allocated for that specific value, then what do we get? Now we get 1. Why? Because the character pointer, or the pointer, is actually of type character, and the character size is 1 byte, right? The variable size is 1 byte, which is why we get 1 byte. Okay. Okay, so as you can see here, this is the other function, or the second function of the presentation slide, which is free, right? So this frees the memory allocated to the pass pointer, and that is exactly what we are doing. And if we don't do this, then what will happen? It might cause overflowing the RAM, because each time we are creating some memory, we are not freeing it, and the the created memory or allocated memories will pile up one upon another, and eventually what will happen? The entire RAM will be filled, right? Okay, excuse my bad drawing. Okay, so that's about it for the two functions, but there are two other functions left, which are calloc and realloc, right? So realloc basically means we can free the memory of the pass pointer, then reallocate memory again. Okay, so the way of writing it is actually just like this: realloc, then the pointer. So the pointer is p, and then the size of memory, right? And of course we have to write it after we allocate some amount of memory, otherwise there's no use of reallocating memory, right? And there's another function which is calloc, right? And if you can remember, it has two input parameters. So this actually helps you to create multiple instances of the same data type. For example, let's say if I want 8 bytes and I want 10 instances of those 8 bytes, which actually basically means 8 into 10, which is equal to 80 bytes. So this memory allocation and this memory allocation is the same. So how does it help us? It helps us if you want to actually write, let's say, a size of a specific type. For example, I want 10 integer type memory allocations, or I want 10 double type memory allocations. Is it clear? So this is how actually we can use malloc, calloc and realloc in the same way, or to allocate the same amount of memory. I hope this makes it a little bit clear, if not totally clear. So if you have any questions, please feel free to ask me. Okay, I'm going to finish my lecture here, and this is the very first lecture, so please forgive any of my mistakes.